Well, howdy there, Internet students. It's Mr. Hermison again. Hey, we're starting chapter 7 right here. We're actually going to get into a little bit of algebra, okay? You guys, sometime back, I don't think it was last chapter, but sometime we learned how to write expressions in expanded form. And we saw quite a few expressions that were the form y equals something times x plus something, where each blank had a number in it. When equations are written in this form, they're called linear equations because they form straight lines. In fact, this form of an equation is so special that we actually refer to it as y equals mx plus b, substituting the letters m and b for the blank lines. The number m, that is, multiplied by the variable. So let's just give you an example. Say we have 3x plus 10. Okay. So the number m that is multiplied by the variable x, which in this case is 3, that's called the coefficient. So the number in front of the x is called the coefficient. And the number b that is added to that mx is called the constant, sometimes constant term. So in this case, that constant term is 10. Those terms will have values, so they might have a negative in front of them. If it said minus 10 right here, then that constant term would be negative 10. Okay, we'll get to that in a bit. But when b is 0, the equation is even more special. It represents a proportional relationship. Now, we did see that before, and a real simple proportional relationship have equations of this form. They're just something times x, like y equals 3 times x. So basically we're saying y is 3 times as big as whatever x is. I'll just make a quick table of that so you can see. We'll do the first few x's here. So this is saying multiply 3 times that value. Y would be 0, 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and so on. So if you don't add anything on, then it's proportional, because notice these ratios of y over x are always the same. 3 over 1 is the same as 6 over 2. They're proportional. It's kind of like they all make the same scale factor. They all, when you divide y by x, you always get this number 3, the rate or the coefficient. Okay? Coefficient is also called the slope of the line, because when we draw a line, it represents how slanted that line is. But in a situation, we call that the rate of change, the rate of the line. Like if you have a situation where you have to pay a rate of $5 per movie for the matinee, that would be the rate of the movie. It would, and if we make a graph of people going to the movie and how much it costs them, we would get a straight line, and that would be the slope of the line. The constant is also called the y-intercept, and we'll get into those, why that is, but it's because of when you graph it, okay, where it ends up on the graph. So mathematicians use a ratio to describe the steepness of a line, and that's the slope, which we call rise over run, change in height over horizontal distance. We did a few problems like this. It's also going to be the rate of the problem, the unit rate, if we divide those up. Why do you think the constant b or y-intercept shows up on a graph? Well, it shows up where the graph crosses this y-axis. And I'll just show you that real quick here. Let's say I have a real simple equation like 2x, 2 times x plus 3. And I make a table of values. And if x is 0, I'm going to do 2 times 0 plus 3. 2 times 0, 0 plus 3 is 3. If x is 1, 2 times 1 is 2 plus 3 is 5. 2 times 2 is 4 plus 3 is 7. If you graph those, the point 0, 3 is right there. 1, 5, 2, 7. these points would stay in this pattern on the graph if I created all those points. And notice where they're crossing the y-axis, right there at 3. All right? We'll study that more. Okay, so let's do some problems. Just definitions. We have to find the coefficient, the rate. That's the number that you multiply by x. Now, if there is no number x, remember that if we had the number 3, that would be the same as 1 times 3, right? So x is the same as 1 times x. There's a hidden 1 when it's not written there, and we're just lazy. We don't like to put that 1 there and write 1 times x. So if there's a hidden, if there is no number in front of the x, then it's 1x, and the coefficient is 1. Okay? The constant is whatever is added or subtracted. If it's subtracted, if it's negative, if it's added, it's a positive. So in this one, it's 5. All right? Now on this one, the coefficient, the number in front of x, is obviously 28. The constant is not there. There's nothing added on. So, and remember, we actually could write plus 0 if we wanted. It's just that adding 0 doesn't change it. So, like I said before, we're kind of lazy. We don't need to do that. But when there is no number added on, there's just a term with an x, then the constant is 0. Okay? Now, I skipped over just a little part of this here that's kind of important. When b is 0, the equation is even more special. We talked about that. I showed you that here. We get a proportional relationship. And when that happens, we use the letter k in place of m. Okay? And that's called the constant of variation. So we write the equation as y equals k times x instead of m times x. All right? So if it's a proportional relationship, we're going to use the letter k. If it's not a proportional relationship, we're going to use the letter m. So in this first one here, this is not proportional because we have more than just the number times x. And in that case, we're going to use the letter m to represent it in the equation. So y equals, it's in this form, y equals mx plus b. In the second one, it is proportional, and the reason it's proportional is because it's just 28 times x. There's nothing else added. So we're going to use the letter k to represent that. The equation is in the form y equals k times x. All right, so go ahead and do, let me do one more that has a negative in it, just so you realize that negative. I'm going to do number 5. The coefficient is the number in front of x, and if it's a minus, then you have to put that minus there. So we put -4 there. The constant is the other number. 12 is a positive number. You don't look at the sign after 12, so you just write 12 for that. It is not proportional because there's more than just some number times x, so we're going to use m for that. Go ahead and do the rest of those 3. For this last one, make sure you put -8 for the constant, because remember, subtracting 8 is the same as adding -8. And this is not proportional because there's more than just 14x, so you use the letter m to represent that. All right, now to complete a table, all you do is do what it's saying right here, like a formula. It's saying take 3 times x. So you take 3 times -2, because this first row is what values x have. So 3 times -2 is -6. 3 times -1 is -3. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. And then you're going to graph those on -2, -6, -1, -3, 0, 0, 1, 3, 2, 6. And since if our table was bigger, we would keep getting more points, they would follow this pattern. We can go ahead and draw in a line and put arrows on the end because we know that it's going to keep going. The coefficient is 3 and the constant is 0. Okay, so this is proportional because it has 0 for a constant. Okay, another way you can tell if it's proportional is if it goes right through the point 0, 0 on a graph, which this one does. All right, for this one, we have to multiply x by 2 and then add 1. So we're going to do negative 2 times 2, which is negative 4, plus 1 is negative 3. 2 times negative 1 is negative 2, plus 1 is negative 1. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. The coefficient is 2. The constant is 1. Since the constant is not 0, it's not going to be proportional. And we're going to go ahead and graph those points, negative 2, negative 3, negative 1, negative 1, 0, 1, and so on. And we can continue at that rate of going up. Draw the line. Notice that this does not cross through the point 0, 0. If it did, it would be proportional. All right. Okay, so many situations in real life can be represented with linear situations. Okay, and in that situation, you can figure out what the constant is and what the slope is, or the slope is actually the rate. Okay, so if you look closely, this online bookstore is selling books for $5 each. Right there, that would represent the rate, because it's a unit rate, how much it costs per item. So, so your rate is 5. That's going to be your coefficient in your equation. The shipping fee you pay for all the books you buy. So you only have to pay it once. That's going to be your constant term. Okay. Since the constant term is not 0, this is not going to be proportional. But now that we know what the rate is, we can go ahead and write the equation, what the coefficient is. And the coefficient goes in front of x, and then we would add the constant, which is 7. Now, we have to think about what does this x stand for. Well, it's 5 times x, so that means that the books that the x is standing for how many books we buy, so the number of books. And then y stands for how much all the books are going to cost plus the shipping fee. In other words, the total charge. All right, so let's do one more together here. Horseback riding lessons cost $12 per hour. Okay, what's going to change is the number of hours that you rent the horse. So let's write that number of hours. Okay, and the rate is the coefficient. That's the $12 per hour. You don't have to pay any extra for this horse. There's no extra fee, so the constant is 0. When the constant is 0 and you have a constant rate, then that is proportional. Okay, and so we get an equation where it's just the coefficient times x with nothing added on. All right. Why don't you see if you can fill in the next two, and we'll see how you do. So the way that Wise's Rent-A-Wreck charges, where they just charge $78 per day, that is proportional. The constant would be 0. You just pay $78 times the number of days that you rent the car. Whitmore's charges per mile, but an upfront fee of $130. So you're going to have to pay $130 even if you only drive it less than a mile. But then you add $9 per mile. Okay. All right, a couple more things about slope. The steeper the line, the larger the slope. The more horizontally flat the line, the smaller the slope. If you get perfectly flat, the slope is 0. If you get perfectly straight up and down, the slope is undefined. It's like the number is as high as it can go, which you could think of it as a slope of infinity, but infinity is not really a number. So, okay, if If you have a positive slope, so from left to right you're going uphill like this one, that'll be represented by a positive number slope. If you're going down from left to right, that'll be represented by a negative number for a slope. Okay, and all right. So check these lines out and predict which line will have larger or so we're going to find, and then we're going to find the slope for each line. Okay. If you heard that, the steeper the line, the larger the slope. I'm going to predict A has a larger slope. Now, to get the slope, you're trying to figure out what the rate is. So notice that at 1, we're up to 25. At 2, we're up to 50. At 3, we're up to 75. So we're going up 25 for every 1 on the x-axis. So it could be like 25 miles per hour, $25 per gallon or something like that. But the slope for A is 25. It's going up by 25. For B, we kind of need to go way over to this 5, and we see that it's going up to 50 for 5. So we're going to do 50 divided by 5 for that one, which is 10. So it's like it's going up at a rate of 10 miles per hour or $10 per gallon or something like that. And the way I got those slopes is I figure out how far it's going up. It's going up 25, and then how far it's going over is 1, and then you just divide those. How far up divided by how far over. So this one went up 50, and that was over 5 hours. Okay. All right. Now, the way you decide if they're proportional is where the lines start. If they start at 0, 0, then they're proportional. So both A and B are proportional. Because the constant term, the y-intercept, where they start would be 0. Okay. So go ahead, you do C and D. I'm going to give you a hint to figure out. Now these are both going to be negatives because of the direction they're going. But we want to try and find points where they're hitting. So I'll give you these. So look how far down those points are compared to how far over you go on each of those points. All right? So how far down am I dropping compared to how far over I go? All right, here's what I got for that. Notice that A and B had positive number slopes, and that's because they were going up and to the right. C and D have negative number slopes, and that's because they're going down as you go from left to right. All right, so just remember that the number parts of an equation have many names, just like you might have a legal name and a nickname. M and K are called the coefficient in the equation, the rate of the situation, the slope of the line, and the constant of variation if it's proportional. You can find that by doing rise over run, like I just did on the last problem. You can find it by looking for the number in front of x. You can look for the charge, the unit charge, how much you get charged for one. Okay. The B is the y-intercept. That's where it crosses the y-axis, or the constant in the equation, which means not the number in front of the x, but how much is added on one time or subtracted. It'll be a starting point on a graph, a head start, a one-time fee, an extra amount, things like that. All right. So that's all I got for you. Go ahead and do your homework, and let me know if you have any questions. See you soon.